All right, hello, hi, greetings everyone. This is Volts for March 4th, 2026. The fate of fossil fuel systems in the mid-transition. I'm your host, David Roberts. It is easy to imagine a fully clean, fully electrified future in which copious solar energy is stored in abundant batteries, backed up by wind and geothermal and advanced nuclear power, and energy-related greenhouse gas emissions have effectively been eliminated. If we manage not to kill ourselves or dumb ourselves back to the Stone Age, a disturbingly large if, I even think we'll get there someday. Maybe 2060, 2080, the year 3000, who knows, someday. But what happens between now and then? In the energy forecasting models, the fossil fuel systems gradually decline as the clean systems gradually grow to replace them. One line goes smoothly down as the other goes smoothly up. But as we know from everything that's ever happened, lines do not move smoothly in the real world. What's going to happen to those fossil fuel systems as they shrink? Are they going to phase out in a way that is economically rational or equitable? Are they going to hand off to the systems that replace them in a way that preserves reliability and safety? These are the questions that haunt what Emily Grubert calls the mid-transition, that murky, troubled period during which one world is dying and another is being born. Grubert, an associate professor of sustainable energy policy in the Keough School of Global Affairs at the University of Notre Dame, has been thinking about the mid-transition, how to study and plan for it, for several years now. With co-author Sarah Hastings Simon, she published an influential paper introducing these medium-term challenges in 2022. Now, with co-author Josh Lappin, she has released a new study in the journal Science that examines in more detail just how small fossil fuel systems can get before they fail entirely, their minimum viable scale, and what that might mean for the design of the transition. The mid-transition is one of the most interesting and generative ideas I've encountered in the last decade, and one of the most interesting research programs going on right now. And I've been meaning to talk to Emily about it for years, so I am extremely excited to finally have the opportunity. We are going to get into what the mid-transition means and how we might approach it in a less stupid and uncoordinated way than is our typical practice. With no further ado, Emily Grubert, welcome to Volts at last. Thank you for coming.
Thanks so much for having me.
This is way overdue. I should just say, Emily, I listen to a lot of podcasts, and they mostly blur together. But I remember after you wrote this 2022 paper, you went on Chris Nelder's podcast, The Energy Transition Show. Shout out to The Energy Transition Show, to explain this and walk through this with Chris. And that individual podcast episode has stuck in my head ever since. I still think about it to this day. It is one of the few sort of individual podcasts I've listened to that actually changed the way I think.
That's amazing.
So, I'm very excited. I wanted to get you on then, but at that time, I was sort of feeling abashed about ripping Chris's guests off one after the other. So I was trying to stop doing that, but I think enough. Statute of limitations is up now, so
we continue to write papers. It's the academic thing.
Yeah, you continue to write papers. Excuses to have you on. So let's just start with. I sort of gestured at the mid-transition in the intro, but maybe just start with what you mean by this, about what is notable about the mid-transition? Why is this worthy of study? And maybe talk about did this just sort of come to you as a concept, or is this like something you kind of bricolaged together over time? I'm sort of curious, like the origin of this with you and Sarah Hastings-Simon.
I love telling this story, actually. So yeah, it's something I've been thinking about for a long time, but maybe the all the way back comment here is I was raised in an oil family. My dad's a petroleum engineer, and so I was always kind of around the industry and always really excited about going into the field. So in college and then in grad school, I helped out with this class taught by Jane Woodward at Stanford that I think probably some of your listeners are familiar with, just called Energy Resources. I think now it's called Understand Energy, but it's a great class that has a ton of field trips. Where this is going, basically, is that I had the pleasure to help teach that class for many years after I'd initially taken it. And so I went on the same field trip a lot of times. And essentially, like, we went to Moss Landing, this giant natural gas-fired power plant a couple hours outside of Stanford over, I don't know, in my case, maybe over the course of 10 years or so. And by the last couple of trips that I was on, they had announced that the plant was going to be closing at some point. And it was actually extraordinarily clear, even to me as a not super expert, that they were not investing in the plant as much as they had been before. I think the last trip that I was on, our guide, who had been our guide for many years, was really visibly shaken and was basically like, hey, I'm sorry I'm off today, but a bunch of my friends got laid off this morning. Ooh. But going around the plant, you could see there was corrosion. They weren't keeping up with painting. There were things that I was worried about the students stepping on. So like this comes from a very physical infrastructure place for me and a very observational one.
Yeah, I think it's easy for energy sort of geeks, wonks, modelers, pundits like me to talk about infrastructure in a way that's very abstract. Yeah. And I think one of the very useful correctives of this work, of all this work, is just to remind us that this is lots of big, complicated machinery. So there's large physical stuff involved, and you have to think about what to do with it. So you talk about sort of the characteristic feature of the mid-transition, and I'd like to hear you talk through this a little bit, is just that you have this situation where one system is growing and one is shrinking. And what's interesting to think about this, and this is sort of like, I mean, I say this purely like as a compliment, like this is one of those ideas that once you hear it, you're like, oh, well, duh.
That's what we're going for.
Yeah, it's like, but why is no one, why has no one been thinking about this? Like, of course, this is something to think about. So like, it's easy to think about if you're building a clean system, I don't know, electricity, pick a system. If you're just starting from a clean sheet of paper, that's one thing, but you're not. Like, that's what this work brings into relief, is you're not starting with a clean sheet of paper. So just talk about that, about this sort of complications of two systems passing each other, kind of.
Yeah. And I think that some of the ways that I talk about this maybe will lead into the minimum viable scale thing is like the sort of obvious next step, which we hope is also one of these things. And this has kind of been the response so far, where half the people are like, this is a ridiculous idea. And the other half of people are like, yes, like I can see that happening around me already. But the minimum viable scale thing that I think is the most interesting is essentially you end up in this place for a while, probably, where the fact that you have one system growing from small and one system shrinking from big means that you have two systems that aren't big enough to do everything for a while. And so they need to be working together, but they're also dynamic. And so you end up in this situation where you actually have a much higher effort period where both systems need to be operable, both systems need to be adapting to the other, and both systems are actually constrained by the other. So you end up with these sort of strange maladaptations at times that are temporary if you assume that this actually proceeds. I think one of the things that keeps me up at night is that we could get stuck in this.
One of the things I wanted to say is just the term mid-transition itself embeds quite a bit of optimism.
Oh, yeah.
in it.
It's optimism, and it's also just sort of, I think, putting a normative line in the sand that we actually have to commit to succeeding in order to succeed. There's a lot of ways to fail. There are fewer ways to succeed. But yeah, and I think what's so important about that, and to your point about the fact that the fossil system is an agglomeration of stuff, is basically we have so much information about it. I think one of the most hopeful things about this work for me is that we know a lot about the system that exists. I think when we talk about clean energy systems, there's a lot of sort of hypothesizing about what it's probably going to look like. With the fossil system, you know what it is, you know where it is, you know who works there. And that gives you a lot of runway to say, how is it going to break? And what do we do about that?
Yeah, but you sort of have the inverse problem, which is that the clean system is, there's a lot of uncertainty and fuzziness, but everybody is highly incentivized to talk about it and think about it.
Yeah.
Here on the other side, we have tons of information. We know all we need to know, but nobody wants to talk about it going away.
No, I think a lot of people know this story, but when Sarah and I set out to write that mid-transition paper, we had actually pitched it as a review. Like we were going to review everything that everybody was obviously working on talking about this stuff. And we started getting in and we're like, oh, there's not a whole bunch on that. But yeah, it's a huge area.
And this is sort of, I think, the core intuition of all this work, which is just that the job of building brand new systems is huge. And it is something that this podcast is about. It's something we've all been thinking about. It is a big and complicated deal that requires some care. But that is also equally true of the flip side, which is shrinking and shutting down and eliminating systems also is big and complicated and fraught with risk and requires care. That's the core here. And as you say, there's nothing. As I was reading your work, I was trying to think of like, have I ever read anything in my 20 years of covering this stuff? Have I ever read anything that thinks in detail at scale about how to shut down fossil fuel infrastructure? And I couldn't think of anything at all.
Yeah, there's it's hidden. It doesn't necessarily present itself that way. But yeah, I mean, it's a huge issue. And I think the other thing that comes up for me a lot is that, yeah, obviously the build out is a huge problem. The retirement is a huge problem. But also when we think about like what environmental engineering looked like before climate change and what a lot of the conversation about environmental justice looks like and what environmental policy looks like, all of the harms that we've been dealing with beyond climate change are in a large way related to these systems, some of which are 100 years old. And so the project of closing them goes beyond just like, how do you actually manage the systems out slowly? It's also uncovering the fact that we have this huge legacy of stuff to deal with that we really do need to plan for.
Yes. It's like the abandoned coal ash pond.
Oh, yeah. Yep.
But like at global scale.
Yeah.
The global version of the abandoned, like, we're going to have abandoned ash ponds all over the world from all of these fossil fuel systems. And I think about like, how are we handling it so far? It's not great.
It's not great.
It's not great how we're doing it so far. Like, you talk a little bit about how the experience of coal is a little bit of a preview.
Yeah, no, it absolutely is. I think we raised this a lot in the various work that we've been doing on this. So I collaborate a lot with Mi-Jin Cha at the University of California, Santa Cruz, obviously with Josh Lappin, who's working with me at Notre Dame right now. But we talk a lot about what the lessons of coal mean for the rest of the system. And one thing that I like to point out to people is just how much bigger the oil and gas systems are in the United States than the coal system. And also, frankly, how much harder they are to replace from a sort of critical services perspective. Like, I think there's a huge amount of really exciting stuff about how far we've come as a society in being able to provide services without fossil fuels. But fundamentally, coal basically makes electricity. There's some edge cases there. Obviously, there's steel, there's some water filtration, great. But like mostly this is electricity, and we've known how to make electricity out of other stuff for a while. The other two are more people, more sites, more services, and harder to replace. And I think if we don't learn carefully from the fact that what we've been doing hasn't worked, as evidenced by coal, we could end up in a really, really bad place really, really quickly.
Before we leave sort of this introductory kind of section, I think one thing that has helped the idea of the mid-transition click with me is just hearing some examples. We can get a little further into one or two of them later on, but maybe just to start, let's just run through like 3 or 4 examples of here's a big system that's in the midst of being replaced by another big system, and here are some of the problems, some of the tricks to that, just so people can get a sense of like the kind of problem you're talking about.
Absolutely. I think my favorite one, and the one that I think clicks for a lot of people, is just what happens with gas stations. So
yes, this is the intuitive
this is the super intuitive one. Yeah, like when you hear EV drivers complaining about the fact that they can't find a charger, like that happens on the way back down too, basically. You get to a system where there aren't as many gas stations as you're expecting, and they maybe go out of business in slightly unpredictable ways, or not unpredictable ways, but in ways that aren't really matched to sort of the optimal placement of where you would want gas stations to support the remaining need. Like that kind of stuff comes up a lot. In the power sector, I think one of the examples that I like to point to is just the notion of actually having to curtail resources. So when people talk about the duck curve or having natural gas peakers have to start-stop to accommodate solar in the middle of the day, or having to shut off solar because there's too much of a base loader available or something like that, these are the kinds of maladaptations that sort of reveal that we can't really run the traditional system the way that we've historically run it, but also the new things that are coming online are entering into institutional structures that weren't designed for them. And it's leading to these sort of strange outcomes that would not probably be the case on either stable side. So either a basically fossil system or a basically not fossil system, you wouldn't really see those problems. One that we get into a lot with the minimum viable scale stuff is on the petroleum refining side, which is basically that we expect product demand to go down unevenly. So we maybe would expect to see gasoline demand dropping off faster because it's easier to replace those kinds of services with, buses and dense transit options, but also with EVs or something like that. It's much harder to conceive of seeing jet fuel demand or like petrochemical demand going down quite as fast. But the way that refineries are actually designed has these products in pretty specific ratios that are difficult to change. So stuff like that comes up a lot.
There's kind of a whole family of petroleum products that are cheap because they are drafting on gasoline. Because the gasoline industry is so mega, they are like byproducts of that gasoline industry. So if the pillar that's holding that up goes away, among other things, like you would expect all these derivative petroleum products to get much more expensive.
Yeah, and I mean, the example that I love to point out to people, because I don't think it's all that well known, is during COVID, Hawaii actually has a pretty unusual situation with its energy setup in that they actually do burn a decent amount of oil for power. During COVID, jet fuel demand dropped, gasoline demand dropped to some extent as well. But basically, the utility in Hawaii had to do a pretty massive wealth transfer from ratepayers to the refinery to prevent it from departing because it wasn't producing its high value products. So basically saying you need to keep making the stuff that we burn in the power plant. Therefore, we're going to pay you to stay online. Like it was a massive story in my world, but very few people know about this, I think.
Yeah, a lot of those little sort of edge cases, like the little edge bits of petroleum product that you need here and there, those are premised on those products being cheap.
Yeah, exactly. And I think, like, not to go super landman on this, where I think the line that you hear from the oil industry a lot of the time is like, well, certainly, therefore, we can't move away from gasoline because look at all these other things. Like your toothbrush is made of oil. Sure, but like my toothbrush doesn't need oil to be $55 a barrel, which I think is the other element of this. Like the value of some of these products for like medical things or children's playground equipment or what have you, like you don't really need the level of cheapness that we have historically seen.
Yeah. And that's just oil. Again, like we're just going through big system after big system. Each one of these is its own sort of nest of issues and problems. And so just to go back to the gas stations, because I think this is like a really great intuition pump. So like, say an individual gas station, the demand at that gas station drops, 40, 50% because people are shifting to EVs. So that gas station closes. But that means that 50% of demand that it was still satisfying is still there and still geographically distributed the same way.
Yeah.
Which means that 50% of cars that was using that gas station will now have to drive, twice as far to the one that hasn't closed. So the question is, if we just allow this process to happen haphazardly based on economics, basically, we're probably going to end up with a result that is highly inequitable, that produces lots of local mini crises, etc. Like, I think this gets to the need, which we'll come back to again later, for planning. Like, I think this is one where people can see if you just let it happen, all sorts of crazy stuff is going to happen as a result.
And I mean, it can even be a little bit worse than that intuition, I think. Like if you do go straight like hoteling theory of all of these things where you tend to see gas stations co-located, so the 4 gas stations on a corner kind of a situation, right?
Oh, well, they all close.
Right. Yeah, exactly. A lot of the time people look at that and they're like, oh, well, if one closes, the other 3 will stay. That's probably not what happens. And especially because so many of these stations get a lot of their revenue from being convenience stores and whatever, like the chance that making an individual decision based on the writing on the wall is going to result in each individual gas station proprietor making the same decision around the same time is actually non-zero. Like you wouldn't necessarily expect one at a time to close, which is also kind of wild.
This, I think, gives people a sense of what we're talking about. So, like, in electricity, we're making this transition. So, like, the clean system that we're building can't do it all yet. So, it's got to operate in a way that is symbiotic with the existing fossil fuel system. And same for the fossil fuel system. It's shrunk too much to do everything now, but it's still doing a lot. So, you have this weird symbiosis. And it occurs to me, like, there's a sort of awkwardness about the symbiosis. Like, I think
Mhm.
just these two systems having to exist side by side, even if everyone was involved in good faith and had the same values and the same goals and aspirations, even in a perfect system, there would be awkwardness and bumps and gaps and missed opportunities. But in actual reality, what tends to happen is that these two systems that are existing side by side are sort of quasi hostile to one another.
Right.
They don't really like one another. They don't want to work together. They don't want to have to depend on the other one. So that's like just another layer of friction almost. Like politically, they're at odds, you could say.
Exactly. And I think one of the things that we think about a lot, just from a communications perspective and a sort of big P politics perspective, I guess, is just the notion that this is something where a couple of missteps could actually set you back pretty hard. And that, like, it's not that you get a new chance every time you try to close something. If you screw it up once, you probably don't get to try again for a while. And that's, I think, also why I tend to be pretty encouraging of the idea that we should overdo it the first few times to prove that we can. But yeah, it's a tricky situation in a lot of ways, because this is something that I think a lot of people that read my work come at it with, like, oh, well, Emily said that this can take us 50 years, so there's no need to try anything. I don't actually think that's true. I think that a lot of our work really points to the idea that we need to try to get through this as quickly as possible.
Let me come back to that in a minute, because I want to flesh that point out a little bit, because I think that will be on a lot of people's minds. But let's just talk about this point, which is something you raise frequently, which is that during this transition period, with these two systems awkwardly side by side, you're going to get problems. And you note, and this is something I don't think we've drawn out yet, but is hovering over all of this, all of these transitions are going to be taking place during a time when climate change is getting worse.
Yes.
And climate change damages are getting worse, and disruptions are getting worse. So you're going to have the awkward handoff from one system to another, which brings its own problems, coupled with the increased stresses of climate change, which are going to also cause problems. And all those problems, you raise this worry, is going to be very easy for ordinary people to look at these problems and attribute them to the attempt to build the new system.
Yeah.
And you say that's a danger. I say that's a sick 100% inevitability that that's going to happen. I mean, how could we avoid that? I mean,
we've already seen it.
I know. Does that not daunt you? Like,
oh, yeah. Of course it daunts me. I think I have this conversation with people a lot too. It's like, this is really hard. Like, what I'm saying we should try to do is really hard. There's not a guarantee that it's going to work, but a lot of the stuff that is being proposed under other circumstances, I would argue can't work. And I would rather try something that's super hard and maybe would work than something that's pretty hard and can't work. But yeah, I mean, I think in this particular case, we have already seen this kind of tendency. Like, the one that always sticks out in my mind, just because I was thinking about it a lot because I've got a lot of family in Texas, but during Winter Storm Uri, like, all that initial conversation was like, look what the wind turbines did. And that's
100%. They were ready to go. They were ready to go with that story. Yeah. They did not hesitate.
Exactly. And like, at the same time, people are dying. Like, it's pretty ghoulish in a lot of ways. But I think one of the things when we think about, well, how do you change that, is really leaning into the planning element. Because if this is sort of happening and then every time something new happens, you're like, well, we could have seen that coming. No one's listening to you. If you're saying, this is what we're going to do for the next 10 years, these are the things we think are going to happen, and we're going to pre-explain what we're going to do about them because we can see them coming, that's a really different scenario that we haven't really tried yet.
I mean, this is something that I did want to talk about because I think I'm probably slightly more cynical and less hopeful than you on this.
I'm rage driven. I don't know that I'm not cynical. I'm just rage driven.
What you are describing is, I guess I would say, for a society that wants to go through a transition like this in a way that is smooth and reasonably coherent, what that requires is a very high degree of social trust.
Yes.
Like, do you have people who, if their leaders come to them and say, hey, we're going to go through some bumps and maybe the occasional blackout and some awkward, whatevers, but trust us, it's for a better thing that we're building. I have trouble imagining that working these days. Like, look around, you know what I mean? Like, look around. Who trusts anybody anymore? I sort of like, obviously, this is not something you can answer, but like, would you agree, I think, that your recommended solution, the only real way to do this well, is through social trust. It's going to require a lot of that.
Oh, yeah. No, I absolutely think so. And again, like, I'm not saying that this is going to be an easy thing or even like the most probable thing to work. But if you do care about like having a better, less climate affected future that also gets people out of a lot of massive environmental justice holes they've been in for generations, then like you have to try sometimes. But I do think that with the trust thing, this is actually the theme of a lot of my work with Mijin Cha on just thinking about what it would look like to do governance demonstrations the way that we've traditionally sponsored technology demonstrations. So we know and we think in a lot of different examples that trying to put public money toward proving a technology can work is a really common move. We're basically arguing, what if you did that to show people, like, we're going to take an example and show you how we would manage this for decline, and then we will do another one, and then we'll do another one, and we'll show you what that looks like until we actually do build some of that trust back. But yeah, that requires people actually wanting to do this, which is also not a foregone conclusion.
Are we aware, is there a historical case where a government was explicit and public about the fact that an industry was going to decline and disappear, and open about the fact that it was going to manage that process? Has that ever happened?
Oh, yeah, for sure. Not at the scale where we're talking about moving 80% of the modern industrial economy to something different. But this is one, every time I'm with Josh on something like this, he's a historian and so loves this question, but I think we can point to a number of examples. So one that actually comes up a lot, and it's funny, people that have gone through them are like, are you sure that's a good example? But, this is hard. This is hard in any circumstance. But BRAC, base realignment and closure, is an example where you have essentially end-to-end governmental control of what's going to happen to a particular base in an area. So that's one that we point to sometimes.
God, how did that work? It looks somewhat miraculous in retrospect.
Right. And like, I think one of the things that we take away from that is it is end-to-end government controlled. It is in a really high trust environment. Like if you're in the military, maybe you don't love the way that structure works, but you probably generally trust what's going to happen next probably will happen, like that kind of stuff. And again, like for people that have been through it, I know that this is a massive simplification and there were issues with all of these, but relatively, I think one of the other ones that we look to in the United States quite frequently is the restructuring of the passenger rail system, which again, also wasn't great, but the way that basically individual railroads got consolidated into Amtrak involved quite a lot of paying attention to what the workers were going to be going through, like what kinds of compensation, job realignment, those kinds of things might happen. Again, they're not a perfect example by any means, but we do have a decent number of examples of somebody basically saying, like, we need to close out this industry and let's do that on purpose.
And we certainly have enough examples of when we didn't plan and just let it happen and it didn't go well. Like if we need any negative motivation, plenty of disasters to point to.
Yeah. And I mean, genuinely, like, I don't want to be super dark humor about this because it is actually really, really serious. But most of the examples that we have seen that haven't been planned have had like really long lasting repercussions. Like I'm in Northwestern Indiana. We still have a lot of primary steel here. And yeah, you can still see the steel industry collapse impact on people's lives around here. And that was 40 years ago. Like,
somewhat legendarily, it is still shaping U.S. politics.
Absolutely.
The loss of those industrial factory jobs
absolutely.
is multi-generational. Okay, so this brings us then to the new paper, which you, as you say, wrote with a historian, Josh Lappin. This, I think, tries to look back and learn a little bit about what does it look like for systems to shrink. And I think the thesis of the paper, the core thesis of the paper, as I understand it, is just that in the real world, the line does not go smoothly down and to the right to zero. There are what you call cliffs. Basically, like shrink to a certain point and then things go non-linear. Basically, like you get collapsed. Tipping points. These are, frequently discussed as tipping points. I don't know why you probably wanted to avoid that bedeviled phrase, but it's a similar idea. So there are different kinds of cliffs. Maybe you could just briefly walk us through, like, what are the sort of cliffs that happen and where did you see it in action?
The one that is probably going to feel the most clear to people is the physical constraint on scale. And basically, I think one of the other ways that I like to motivate this intuitively is people are sort of familiar with the notion of economies of scale, where you can do something different because you're big.
Right. So this is diseconomies of non-scale or
Yeah.
whatever.
Yeah. Exactly. You get to the point where I think it's pretty clear to people that if something is too small, it doesn't behave the way that it was intended to if it was designed to be a lot bigger. But the physical constraint kind of thing is just like, you actually can't move that little stuff through that pipe, or like that valve won't work if the pressure's too low, like that kind of stuff.
Yeah. So you mentioned petroleum refineries in this.
Yep.
So like at a certain point, if you lower throughput below a certain level, the physical plant itself won't work anymore.
Right. Yeah, exactly. And I think one of the things that we have been trying to sort of communicate in the modeling space for a while too here is that level is probably a lot higher than people think. There's a tendency to be like, well, we could just run one refinery at 100% or whatever it is. But even the industry itself suggests that turndown capacities for refineries is probably in the 60 to 70%-ish range, which is much higher than like 2 or 3% that you see in models sometimes. So I think that that's one, but more specifically on the physical constraints here, just to kind of go back to what we were talking about with mid-transition stuff and refining earlier, you do actually have a situation where you can't make the precise product mix from the kind of crude that you're using at some point. Maybe you could build something new, you could invest in a new process, you could invest in new equipment, but without doing that, you can't. I'm a civil engineer, trained as a civil engineer and as a sociologist. And I think one of the things that I'm always pressing people to do in models is tell me, like, are you saying I can't do that because of a money issue? Or are you saying I can't do that because I actually just can't? Because like I can solve a money issue more easily than I can solve a physics issue. Right. So it's that kind of stuff.
I love it that you have those two cross disciplines, because like those two ships very frequently pass in the night without much communication with one another. So yeah, I know. I love it that you're bringing them together. So that's at like 65, 70% of demand. So that's early in the process. That's not even that far down the road where petroleum refineries will start closing. And then again, like that 65 or 70% of demand for whatever that product was still exists, and will now have to get it from some other refinery somewhere else, presumably at more cost, at higher transportation costs, et cetera.
If they even can. I mean, this is one of these things where it's like, how do you move it? Is it a pipeline? Is it a truck? Is it a boat? But like this kind of stuff, we're seeing this unfold in California pretty dramatically right now. Obviously, the Hawaii example I gave earlier showed this a bit too, but like this isn't all that hypothetical, actually.
Yeah.
But yeah, it's a big deal. And I think one of the other things that it kind of points to when we think about how do you actually manage this is that you might not actually want the most efficient and the biggest units to be the ones that stay online. Like if you're actually trying to see how does the system shrink gracefully, maybe I want the little expensive plant because its 65% is a smaller number than the 65% of the giant, very profitable plant. But just like thinking about stuff like that does sort of take us out of the realm of how we've traditionally thought about this.
Right. And you will not get that result if you just allow the market to run.
Probably not.
If you just allow them to close based on pure finances, you're not going to get that sort of rational.
Yeah. Ordering by profit rather than service need is not probably going to work if you actually care about these as critical services for society.
So there's also a financial cliff.
Oh, yeah.
And this is interesting to me because I think this is also one where we're not quite there yet, but you can sniff this one just over the horizon as well in a couple of systems. So talk about like who's threatened with a financial cliff and what does that mean?
Yeah, no, it's also really funny too. As we were writing this paper and trying to put together some of our examples, it was like, these are all threatened by all of these issues, but like, which one's going to hit first is kind of an interesting question. So like, we talk about the natural gas system as a place where the financial cliff seems to be the most binding issue. And obviously you can think about physical issues there too. Like gas takes 5 days to move from East Coast to West Coast or so. Like you can't actually move gas super quickly. I have this longstanding obsession about what the minimum pressure you can have in certain kinds of transmission pipelines might be, like this kind of stuff. But from a financial perspective, gas is interesting compared to oil and coal because it serves three really, really different types of purposes. So coal makes power, oil makes transportation, gas makes industry, home heat, and power, basically. And so if you see those three different uses declining at different rates, which is probably what we expect under most deep decarbonization scenarios, all of a sudden you have a situation where you had 100% paying for, the 2 million miles of pipeline that we're talking about here. Now you maybe only have 70%, and that 70% is maybe the part that is burdened enough by those costs that you're going to see defections and things like this happening. But just the fact that you no longer have sort of the scale of multiple customers that are all paying into a very expensive set of fixed infrastructure becomes really, really important.
Right. So just to spell that out, like you've got all these physical pipelines built and they require a certain amount of money and maintenance. Those are the fixed costs. So even if like 100 people get off your natural gas system and go to heat pumps, you still have all the same pipes,
Yeah.
all the same on all the same fixed costs. So now you're just dividing those fixed costs over a smaller user base. And the problem, again, to return to a theme, if you just let this happen by market forces, what's going to happen is it's going to be the wealthiest who leave the system first to the new, better system. And thus, the people who can least afford it getting hit with these perpetually rising costs.
Yeah. And I think that that's true within like the distribution customers thing, even at that level. So I completely agree that that's the likely outcome here. What I think is also kind of wild is that we expect this also to just hit like residential customers probably harder than others, because if you assume that you have a lot of power backing off in a situation where you have a lot of wind and solar or something, and so you're using less gas for electricity, all of a sudden you have these big industrial users that are actually making money off of buying the gas, departing and leaving those costs basically on other industrial users, which maybe face sort of a similar pattern, but maybe have less of an ability to move off gas, and then your residential consumers. And so you have this situation where everybody on the residential side, and especially the people that are least able to afford it, gets hit with these massive fixed charges. And like, even now, I would argue that we're not that far into this transition, frankly. But even now, like you can go on Reddit and see people complaining and being like, yo, what is this massive fixed charge? I barely used any gas last term. Like it's already a problem. And in a heavily energy burdened society, this is the kind of thing that kills people.
Yes. And this is the what they call the death spiral, the price death spiral. And again, kicks in well before you're anywhere close to zero.
Yeah,
like
absolutely.
Kicks in, and I don't know if you've done the exact numbers on the gas, on like sort of residential gas distribution, like what level of exit is going to get you this cliff?
Yeah.
Like, do we have a sense?
It really depends. It really depends on how proximate you are to either big distro lines or big transmission lines. Like if you're in a pretty dispersed area that has a lot of industry and you're just like a couple of guys using it residentially because you're in a small city, that looks really different than if you're next to a gas field with a bunch of local storage. So it depends a lot. But yeah, like it's not close to zero.
The other kind of cliff, which I find really fascinating, is what you'd call a managerial cliff. And this comes in to coal power. And this gets back to sort of we briefly touched on before, which is that like, I think what a lot of energy models envision is for a lot of fossil fuel plants to just be used less and less, but to still be there for backup. Like
exactly.
This is, people are very familiar with this. Like you'll need less and less and less backup, but getting to zero backup turns out to be super expensive. So you keep your natural gas plants online for whatever your 2 to 3%.
Or quite frankly, many of the deep decarb models say build out more gas because you need so much extra capacity because you essentially need a 1-for-1 replacement for peak.
Yes. And people are talking about leaving coal plants online for similar reasons now. But then you raise what, again, like once I read it, seemed obvious, which is that like, who is working at this plant that is running 3% of the year? Who has the expertise and the skills and the schedule and all the rest of it, like the managerial stuff? Like, who is doing that at a ghost plant?
Yeah, 100%. I want to talk about labor for a second, but I think one of the things that we are trying to also raise with the managerial constraint is just that you have different asset owners making different decisions in sort of a privately owned, privately managed system. So in this particular case, basically, if you have every plant and every mine making its own decision without coordination, you end up with somebody rationally decides to close a coal mine, and now there's a whole bunch of plants that can't operate because they can't get coal anymore. Like, that kind of thing can happen. But yeah, on the labor side, I get this question a lot of basically like, why is there a special consideration for fossil fuel workers in a lot of these transition conversations? And I think like I'm a big universal services person. Like I have said this a lot of times, but like I don't think you can do the energy transition without universal healthcare and a variety of other kinds of things like that, just because it's such a barrier in a lot of cases. Plus, it's I think the right thing to do.
Remember can we just pause
Yeah.
and just think back to the Green New
Oh my gosh,
Deal
yeah.
argument? Why is there a job guarantee? Why is there health care? Why is there elder care?
It would be nice if people felt like they could live.
I know. Like, what do we need during times of turmoil? We need something steady. That's the whole point of social safety nets.
Exactly.
I love that you make this point.
I'm so glad.
Like, so much of the risks of energy policy would not be risks.
Exactly.
If you didn't have people who are like, could die if they lost their jobs.
Yeah. Or like, what am I going to do with my kid? Yeah, exactly. But I think when we get to the like, why have special programs for fossil workers? You kind of got to this a little bit earlier too, but you were talking about extraordinarily high hazard infrastructure systems, just in the sense that something going wrong can be very dangerous. And I think there's a real safety element to a lot of this, both for people, for the environment. That goes for workers as well as people that are nearby. But a situation where you basically have infrastructure moving into operational conditions that it's never had to face before because it's running way less than it used to. And we've gotten into this with hydro a little bit too. But also facing new risks from climate change and also facing the fact that, like since I was an undergrad, people have been talking about the demographic cliff in fossil fuel labor. Like people have not really been going into these industries at quite the level that was expected for a while. But you end up in a situation where essentially you don't have anyone who knows what they're doing unless you make sure that the people that know what they're doing are willing to still be there. And it's hard.
A point you frequently make is, it's going to be difficult to talk a 22-year-old into learning how to do this, maintain a coal plant, on the premise that he's going to tend a dying coal plant for 10 years, and then all his skills will be mooted.
Yeah. And by the way, like from a cultural perspective, maybe all your friends hate you because you work at a coal plant. Like that's a really hard thing to walk into. And so, there's interesting ideas about how you train people to work in like, you're going to learn how to be an operator that also is like trained for closeout and trained for post-closure things. Like that's a conversation that I think is an interesting one worth having. But even just being able to tell people like, we actually need you to keep our communities safe. And yes, this industry is going to be gone basically as quickly as we can make that happen, but you're going to be okay afterwards. That kind of thing is, I think, valid here.
Again, it would be easier to convince the 22-year-old if the 22-year-old knew that he was not at risk of like going on the street if he lost his job, right?
But I mean, it's also easier to convince the 45-year-old who actually has other options to stay.
Right.
It's that kind of stuff too.
You can drop beneath a sort of managerial or logistics or labor cliff where you simply don't have the people and skills remaining to run this thing that you are rarely using. So all these cliffs, which kick in nonlinear effects. One aspect of this I wanted to touch on briefly, which is sort of interesting, is you could imagine if we were explicit as a society where, we're phasing out natural gas, and we did it in a rational way, that you could imagine sort of like natural gas companies teaming up to do this in a rational way that made sure everybody was cared for. But they can't do that. It is explicitly illegal for them to collude with one another and, manage their businesses sort of like that. What do you do about that? Hey there, everybody. Don't worry. I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition, and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts. People using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. It is explicitly illegal for them to collude, with one another and, manage their businesses sort of like that. What do you do about that?
Yeah, well, I've got one great solution that industry hates. No, but just to be a little bit more serious, I think, this is a really important point, and it's one that I think is not that well understood. We talk a lot in the mid-transition conversation about the need for coordination. And like we were talking about before, this is stuff. It's stuff we know about. It's stuff where we basically know even like, that valve is not great at this plant if you know who to talk to. Like you can get a lot of detail on this. So hypothetically, you could kind of get to a situation where you say, well, I know I need about this much flexibility in the system. These kinds of services I want to make sure I 100% have. These ones I could be more willing to let go a little early, whatever it is. But you can get around a lot of the problems that we predict here by planning in advance. We come to the conclusion often, and I don't want to speak for all my co-authors, but I think that most would agree that essentially some sort of public management, I often talk about this as public ownership. I get the point that like what I'm really talking about is a situation where the public has full control over who's operating, how much, when does it start, when does it stop, and what happens to the revenue. That looks a lot like ownership. There may be some legal structures that wouldn't technically be ownership, but that's what I'm talking about. So we kind of come to the conclusion that that's essentially the only option you have if you do really want to make sure, first of all, that this happens, and second of all, that you're not really stranding people.
So you're talking about the people owning the means of production,
right?
Emily.
Yeah, I am talking about that exactly. But I think what we see so often in like why you actually need that to happen is because if you don't have some way to decide timing, order, and output, essentially, you lose the ability to figure out what's going on. And I think with this antitrust stuff, where that becomes important is people will kind of say, well, the market could solve this. None of these things are free markets. There's a really good reason for that, which is that they're critical services. And so we regulate them in ways that actually reduce the freeness of the market, but also they're not things that we're willing to let collapse. We know that's true. So the fact that you have a situation where even if you did want to have all these individual actors sort of deciding amongst themselves as the experts or whatever the argument might be what to do next, they can't. Most of these industries are not allowed to be in the same room with each other because it starts to violate antitrust. Like they're not allowed to do that. And so you need some other solution, obviously from that perspective, plus from a bunch of other ones too, I'd argue.
Because when I think about them colluding, what I imagine happening is them getting in a room and discussing how can we stop this? That's what I imagine when I hear them colluding. Like, how can we stop this transition from happening?
Yeah, and I think that that's what a lot of people have in their head, but also saying like, well, you stay open and I'm going to close. That's also collusion, and that's Enron, basically, in a lot of ways, to be like really shorthandy about it. But yeah, like you can't do that, even if it were for what we think is a societal good. I also get the question a lot, like, well, can't we just regulate this? It's like by the time you actually know enough to regulate something, then you're just making the decisions anyway. Why spend the time to expose yourself to that? Plus, I think the single biggest thing that you really can't do, other than via something that looks a lot like public ownership, is to compel a plant to stay open. And I think that that's actually really important in this circumstance. This is where I get hit a lot of the time with like, oh, Emily, you're trying to delay the transition. This is just an excuse to keep fossil online for longer. That's not what I'm saying. What I am saying is that there are certain circumstances where in order to preserve a critical service to the point where your other thing is ready, whether it's because you had some sort of construction issue at your new replacement thing, or you're just a little wrong about the timing or something like that. If you've got a whole bunch of private businesses, one of the fundamental business decisions you can make is this isn't profitable for me and I need to exit. There are almost certainly going to be situations where we have societally critical services that are not profitable. And without some mechanism for actually compelling operation, you cannot guarantee they'll be available.
Yes, that's the root of it.
Yeah.
I want to get to that point about delay, but first, just the last point on this, just because it delights me. So I would like to hear you talk a little bit about, you say that these systems are networks of networks.
Yes.
And that as they shrink, what happens is that, so like any of these given networks is a bunch of sort of sub-networks sort of coordinating, operating in concert to create the larger system. And as you say, one of the things that could happen as these systems shrink is that these subsystems, these sub-networks, can come unaligned. And you refer to this as rapid unplanned desynchronization, which is a term I want to get on a t-shirt or like name an album or something. You know what it made me think of? It made me think of Gwyneth Paltrow and Chris Martin conscious uncoupling.
Right? But like
that?
The opposite of that.
Yes, this is unconscious uncoupling.
Yes.
It was right there. It was right there for you. And you
didn't take it, unfortunately.
So talk a little bit about what you mean by networks of networks and what it means for these networks to become rapidly desynchronize.
Yeah. And I think this is one of these places too where, like I said, I try not to be an optimist for no reason, but I think one place where there is a lot of opportunity here is just to kind of point out that we're actually, as a society, really good at figuring out how to do things. One hallmark of that is that we have a lot of really tight interconnections across these systems because we figured out like there's a byproduct over here that I could use, or I could take advantage of the fact that this infrastructure is available to me or whatever. That makes it a little hard to unravel, but I think it's also sort of testament to the notion that we can do hard things. That said, though, in this particular situation, we have a system that has built up a bunch of different fossil infrastructure networks on the assumption that they're going to be basically indefinitely present and probably indefinitely growing or at least staying stable. Once you take away that assumption, a lot of the kinds of baseline assumptions that you can make about how the system runs start to fall apart. And so, like, people that have had stats in high school or whatever are probably familiar with the idea that like there's a bunch of tests that you get drilled into your head that you can't use if the basic assumptions that the test is made for aren't in place. And I think what we're basically arguing here is that there's this huge opportunity for a bunch of assumptions that people have just always assumed are going to be in place forever no longer hold. So stuff like going back to the pipelines example, because I think it's maybe the physically most clear to people from just a mental image. You have these networks that do sort of depend on the notion that there's going to be demand for gas. So I make this pipeline a specific size because I know how much is going to be going through there. I'm a water resources engineer specifically by training initially. And so the other analogy that I like to bring in here that people may or may not be familiar with, when you start seeing a lot of low-flow toilet development in cities, sometimes this causes really big problems for sewers because the sewer was designed assuming there was going to be a certain amount of water to move solids, right? Like, this is sort of non-obvious, but yeah, it can cause really big problems when there's not enough water. So you think about that kind of thing, translate that to these big systems that are sort of complex networks of like, I'm pulling ethane off the Eagleford natural gas production to make plastic, and I'm pulling the methane to go up to the Northeast during the winter and these other areas during the summer, and I'm moving pipelines, I'm switching their directions. I need a certain amount of flow to move all of this. This is all very complicated, and once you start moving in like plants, railroads, all these other types of things that start integrating here, it's all super interconnected.
Like, is the worry here that like if one of these subsystems sort of breaks or shuts down that you can get kind of a cascade because you have all these dependencies?
Absolutely. And I think the other worry is just you might not see it coming because you might not realize you depend on something.
Yeah, I mean, that's one of the funny thing about fossil fuels, right? It's like when you're dependent on something for 200 years, a lot of it just sinks into the background in a way that you would like only become aware of when you try to change it.
Right.
So if I'm just a normie and I read about this and I hear about this idea, if I'm just an ordinary citizen and you tell me, you know, as we're growing this clean energy system, there's this risk that the fossil energy system will hit one of these cliffs and kind of start to shut down before the clean system is robust enough to take over. And so what we should do is take measures to keep the fossil system healthy and alive until we are certain that the clean energy system is robust and ready to take over. And of course, once you establish that framework, you're just going to have people saying, oh, it's not quite ready yet. So it sounds like as you raise all these warnings about these extant systems breaking down in ways that are unplanned or that could have negative effects, why shouldn't someone just take from this, well, we better go real slow.
Right.
We better go real slow and real carefully and tend to our fossil systems carefully as we go so they don't fall apart too early. Like, why isn't that the intuitive takeaway?
Yeah, I mean, that's what a lot of people do take away. And I think it's a bit of a misread of what I'm arguing, actually. So if I can reframe it, the way that I often do talk to people about this is there is a real risk that the fossil system is going to fail in all of these sort of predictable ways. And therefore, that means we really need to accelerate what we're doing to build out the whole new system. But it's a slight change in the way that it's framed, but I think it's an important one. Like, this is also a call to move faster in replacing it because we don't have as much time as we think. And I think that that's really one of the big arguments about minimum viable scale is people kind of look at this and they're like, we're good for another 20 years if we screw this up.
Yeah, right.
But yeah, and I think when we get into the planning conversation, one of the other arguments that I think is really important here is that the coordination and the planning actually needs to involve the clean side too. We don't talk about that quite as explicitly because there's so many other groups that are working on that, but this needs to be an integrated conversation. Like, what's going to be ready when, and therefore when can we let certain things go is two sides of the same planning conversation. I think where that gets also really important, if you're just looking at the fossil side, is being able to say like, oh, we actually see a really good opportunity for this, and this to exit at these points. Hey, clean system, you need to be ready for that. I'm going to give you a date. Like, those kinds of things, I think, are actually much more what we're arguing than like, we need to make sure the fossil system is good. It's more, we need to really, really review what are the energy services that people are using, what's providing them, and what are the mitigation factors when we see something fail, and are we sure that they're there, I think is much more the conversation than how do we keep the fossil system alive.
I guess this is where your political hopefulness, where I stumble on it a little bit. Like, if I'm imagining a social conversation happening in the context of we've all decided we're doing this transition, right? In that context, then, oh, fossil systems might break down earlier than we think, leads inevitably to, oh, well, then let's build the clean systems faster, right? Like, in the context of you've decided to do this and you're doing it,
yeah,
that's the obvious conclusion. But we haven't made that clear societal decision yet. And in the absence of that decision, it seems to me that the decision just to keep the fossil fuel plant on a little bit longer is easier socially, easier politically, easier, just less friction. You know what I mean? Like, in the absence of that overriding, compelling mandate for a transition. Do you know what I mean? Like, a lot of these troubles are just going to seem to me argue for delay.
Oh, yeah. No, and I think that that's exactly why I always emphasize, like, this doesn't have to work. Like, we could fail. And it sort of does depend on deciding to do something. Like, two quick anecdotes that I think about a lot in this context. One is I was teaching life cycle assessment last year, and we went through this, like, it's a 3-hour class, and we went through this long process of basically trying to get the students to see where are the greenhouse gas emissions coming from the system. We spent like 3 hours on this on the board. It was a whole thing, like tons and tons of data. And at the end, one of my students was just like, all this tells me is we need to shut down the coal plants. Like, couldn't I have figured that out from the beginning? It's like, yeah, you could have actually. And like, we do know that there's like a really obvious answer here that we don't necessarily really need to spend a whole lot of time on gathering a bunch of data on this, I guess is my point. It's like the work is figuring out how do we do that, like getting people aligned with the fact that we actually do need to do something about climate. The other anecdote that I often return to is, I think I mentioned I went to Stanford, and one of the things about that university that I found fascinating forever is they set out to be an elite university. And I think what I take away from that is, like, when you look at some of the initial founding documents, they weren't just like, we're going to be a college and see how it goes. They're like, we need to think about, like, over the next 100 years, how are we going to make sure we're elite? You can't reach some of these outcomes unless you plan on doing it. And so, like, if you don't assume this is what I need to do in order to succeed, you're probably not going to succeed. So yeah, I'm not saying this is going to be easy or even a guaranteed level of success, but I don't think the other alternatives can work, basically.
Yeah. I guess I just look around at the state of things and wonder, like, what we can't even collectively decide. Much simpler things, I'll just say. Much simpler and more obvious things we can't seem to decide.
Yeah. So, like, if I'm, it's the end of the day, my time. So if I'm being a little loose about this, like, let's please stop just talking about what exactly the subsidy level on something esoteric should be and actually try to do the politics here would be my request. But yeah, this is a really, really hard thing to do. And it's not the kind of thing that we can solve by just sort of seeing what small tweaks we can make around the edges anymore.
I guess I asked this before, and you did answer it, but it's just like I stumble over and over again. I'm just like, the idea of Americans, talking Americans into basically assuming ownership, effective ownership of several legacy industries. I'm just trying to imagine the political circumstances in the United States where you could persuade Americans.
So what I think is really interesting is from my conversations with people, I'm not sure how much persuasion is actually necessary here. I've been shocked at how on board people are when I just talk about this, like in kind of normal conversation contexts, I guess.
Specifically nationalizing industries?
Yeah. I have a shirt that says nationalize and I wear it around town sometimes. But like, yeah, but genuinely, like thinking about this, what I think is really interesting is if people aren't really on board, one of the things that I've noticed gets people on board real quick is basically pointing out that all of these really significant environmental legacies basically will accrue to the public eventually anyway. Taking over the industries before they just go bankrupt means that you get to control the revenue on the way out rather than just taking it as a Superfund site, basically. But the other one, I mean, the number of people that I've talked to that actually just sort of assume this is how it is already is way higher than I would have expected.
That they are nationalized?
Yeah. Like people just assume this is public. And not everyone, obviously, but a lot of people do. But I mean, even where I am, I live in a relatively small Republican city. We have a municipal utility we buy from a co-op. Like this is something that is just pretty normal in a lot of cases that I think we underestimate how challenging this would be, because when you really start to talk about like what is it and why, that nationalize word throws people off and makes everybody assume that like if we go and A/B test this, it's going to be a disaster. But if you actually talk to people and you're like, hey, do you think it would be good to make it so that people can't just go bankrupt and leave these massive liabilities and maybe also we get like a better climate future out of it? I think a lot of people are like, yeah, obviously. I've been surprised at how easy this conversation is, to be honest.
That's really interesting. And like one other aspect of this, which is probably worth it's like a separate conversation, but is worth keeping in mind for transition people, is that, as you say, these are private industries that we're talking about. They're on the oil side and gas side. On the liquid fuel side, all of those are being transitioned to electricity.
Yeah. Going into utility mode.
Yep. Which is not privately owned, right?
Well, a lot of it is.
Like, but much more tightly regulated.
Yeah.
Much more direct regulation. So like PUCs, I don't know if people have really internalized
I know.
If this really happens, PUCs are going to go from backwaters to like running economies. Like you're going to be regulating the entire economy.
I'm glad you brought this up because I've been thinking about this in some form since I was a grad student, basically. I have an early paper from like 2010 that was basically making this point. But yeah, like absolutely, moving everybody over into electricity moves you into an entirely new institutional and regulatory paradigm that, like, again,
much more managed.
Yeah, in the spirit of planning, though, it would be good for them to know that's coming. Like, you know, back to the point that we were talking about a minute ago, too, where these aren't free markets by design and for good reasons. There are probably more spaces where it would be useful to try to realign these with socially good outcomes. But like, we are working in a paradigm where we have a lot of social recognition that you don't really want a situation where a provider can just walk away from you in the middle of an ice storm and say, like, you get to die because I'm not going to make enough money off of you. Like, we've decided that's not okay already. It's not that big of a leap to think about how this plays with some of the climate stuff.
Well, by way of wrapping up, I could talk about this forever. This is like, I think by now listeners will have clued into the fact that like, this is sort of like a lens through which you can see the whole, you know, it's funny. I started thinking about it. I was like, well, what is the mid-transition? I was like, well, there's before the transition and then there's after the transition. All the rest of it is mid.
Most of it.
Right?
Yeah.
You're just referring basically to the transition, which just sort of highlights how remarkable it is that we've been talking about this. It's almost like we don't believe ourselves.
Yeah.
Like what you're doing, this is the logical train of thought you do if you take it seriously.
Yep, exactly.
We're going to do this.
Yeah, if you assume you're going to succeed, you have to deal with these issues.
Yeah, I think it's so telling that like you're the first person basically like raising these issues. I think it goes to show that like I'm not sure we really do believe it. You know what I mean?
Yeah.
Like, I'm not sure, even as much as we've talked about it, all of us have talked ourselves into it. I'm not sure we really genuinely in our hearts believe it. I know that like your average senator or like, a poll, like I really don't think they genuinely believe it. So all this is just like follows from taking seriously that you're going to do this transition. One final aspect I want to ask you about is the international aspect, which is a whole, again, like a whole, like once you're looking through this lens, like, oh, so many questions jump up about the international situation. Like one of the things that sort of jumped out at me is like this research really highlights the merits, the benefits of leapfrogging.
Yeah.
They're always talking about like African societies just go straight to clean energy, don't go through the clean energy. This really puts a fine point on here's why you don't want to be messing with two systems at once if you don't have to.
Yeah. I mean, even I think the example that people have raised with me too is like China going from a very coal heavy grid to not really investing a ton in gas is probably good. Like getting stuck in another system that you have to transition away from such that you have to do this more than once is sort of a worst of all worlds.
Yes. You should go straight to clean when you can. But I don't know. What are the other sort of like, when as implausible as sort of like rational national planning strikes me these days as I look around at the state of things? Then you have to think about, well, what does rational international planning look like? Because all these same considerations apply.
Yeah, mostly
at the global level.
I think
basically.
There's two really important differences but yeah, I agree. Like this is a problem that people should be paying attention to everywhere. We tend to use American examples for a variety of reasons, but yeah, this is certainly an issue everywhere. I think the good news, bad news here is, I guess bad news first, the US is probably an easy case for doing this in a lot of ways because our infrastructure is very old. We're actually working in situations where a lot of proponents probably also are not really excited about keeping some of these assets online for that much longer. If you're talking about a 120-year-old refinery, like that's not something where you're worrying a ton about the stranded asset, and you probably are very concerned about your liabilities for closure. So the fact that we have this old infrastructure means we're not stranding that much comparatively.
You're open to a discussion about closing.
Exactly. The good news from a managerial and institutional design perspective, I think in some ways, is that the US is essentially unique in private ownership of energy systems. And that actually does have some really significant ramifications for how hard or easy this is to do in different places. But basically nowhere else is that the case predominantly.
Do you think that makes it harder? You think that makes it harder for us?
I think it makes it harder for us because we need to do two things instead of one, like actually get to the point where there is some sort of public control and then actually do it. I know like people are going to point out there's been a lot of privatization internationally. That is true, but just something as simple as private mineral ownership doesn't really exist outside of the US in a couple of sort of strange Commonwealth edge cases. So stuff like that actually I think does matter quite a bit. So similar conversations, different valences, different flavor, but I think the overall point is everyone needs to plan for this. And if we plan, we're a lot more likely to succeed than if we don't.
Yeah, and I guess when I think about like planning nationally, I can kind of wrap my head around because then like, you got a poor region, well, you need to send some assistance to the region or whatever, but at least it's like a coherent national economy. But when you're planning internationally, like when you start thinking about what is it going to do to international relations for oil to be less valuable, what is that going to do? Like there's a whole network. Do you know what I mean? There's like a whole network of international relations, detailed international relations built on this fundament, built on this foundation of oil politics, basically. And like all of that is going to rapidly desynchronize, to coin a phrase, like, and who knows what all that stuff. I wouldn't even know how to plan for that stuff. I mean, it gets so complex once you expand your lens.
No, for sure. And I mean, again, another slightly good news thing about the US example, which I think is why there's a lot of reasons why it's useful to start here. One being, I think we have a higher ethical responsibility for moving than most countries, and we just are wealthier and have a lot more capacity to do so. But also, like, a lot of people don't realize the US is essentially energy independent at this point. Like, there's the strange cases on the side where we need certain kinds of crude versus others, but like we've been a net exporter of oil for a few years now. We produce more gas than we need. We produce all of our own coal. We produce all of our own renewables. we are in some ways kind of an isolated case of a really big economy with largely amortized infrastructure and a lot of money to make something else happen. So I don't know. I think if I do go into one move of optimism rather than just like, welp, I guess we got to try something mode, like there are a lot of conditions here that do make it likely that we could actually do a really good job with this and make a lot of people's lives a lot better.
Yeah, we are. I mean, we are positioned to be good if we wanted to to be that way.
It's worth a try, TM. Yeah.
This is a lot. It's a lot. It's just like a new lens of looking at the world. When you try to decompose this program into steps, what are next steps? Is the main thing that you just want U.S. leaders and policymakers to acknowledge and embrace the necessity of planning? Is that sort of like, that kind of has to happen, right? For any of the rest of this to
I think
happen.
so. I think that's honestly, it's a few steps down the line, unfortunately. I mean, if that just happened, then like awesome. But there's a couple things that I think are smaller chunks maybe. So one being this notion of actually trying to do governance demonstrations. That does take some policymakers deciding to do it or allocate money. But I think like building those mechanisms for trying to establish public trust and showing like what is it actually going to take to do something like this.
A state could do that, right? A state.
Yeah, absolutely. A state could do that. And there's a couple of examples that I think are really, really good for opportunities here. So the one that Mijin and I have written about quite a bit is the Powder River Basin. I think another one that Josh and I are actually quite involved with right now is the California refining system, like both pretty big, but a small number of assets in a particular geography. There's a few others like that that I think could be pretty interesting.
And are being planned, are being dealt with in a reasonably rational way?
No, but could be, I think. And there's more steps to that too, but I think that that's a first step. I don't think that going straight to like, hi, we own everything, what do we do next is really the move. I think we do need to actually prove that there's capacity here and build that quickly, hopefully. But I think the other thing that is much more a call to the modeling community, I guess, is I get really nervous about the way that a lot of energy systems models sort of presume the way some of these things could unfold that I think have made a lot of policy contexts a little bit more complacent than they should be about how much time they have. And I think maybe that's the other lesson here.
Just is all the smooth lines we're talking
it's
about,
all the
right?
smooth lines. And like, obviously you can have different opinions about how fast you think this should go. But I think one of our arguments is like, A, you should want this to go very quickly. And B, like it might go faster than you're intending it to, even if you are thinking about this, if you don't realize that there are these big potential failure modes. And so having a situation where like suddenly you just don't have refined products in half of the country, like that's bad. And like if you know that's coming, then you can be like, cool, I have a whole big plan. But I think a lot of models that are out there that say things like, yeah, don't worry about it, we'll always have natural gas backup, or like, don't worry about it, we will always have the ability to make jet fuel, so it's fine that airplanes are phasing out much more slowly than cars. Like those kinds of things make people not realize how much work there is to do, and then we don't do it. So it's good to know how big the challenge is, I think.
But on the other hand, I mean, if I'm speaking for an energy modeler, like once you start looking into the actual tangible physics and construction of these sectors versus just sort of highly abstracting them in a model, you get into wild complexity. And trying to do that for every sector, for every country, for every region, sector, industry, really look into the empirical details. That's just like, seems like exponential complexity to put on the shoulders of a modeler.
It is, but I think I would argue that it's maybe not ethical for modelers that want to be deeply policy engaged to try to do a really abstract national model rather than to try to get into this at high levels. And yeah, like, you know, there are things we can do just because it's interesting scientifically, but especially for these models that are really saying, I'm going to go to the federal government with these and say, let's do this, there is a little bit of a responsibility of knowing where those edge cases are.
Yeah, and it also seems like they're not necessarily rule bound. It's not like you could just add more rules to your model guide and do this. You really have to go do some looking at the real world.
Yeah, I'm a huge scenario guy, like huge scenario guy. And I think that that's actually really important in these situations.
This is fascinating. It's sort of funny that it all sort of reduces to like, let's think about how the transition's going to work, guys.
Yeah, it's like maybe trying would help. Yeah, exactly.
Instead of just winging this, what if we did it on purpose? A delightful idea. So anyway, I really recommend everyone to your paper in Science. It's very readable, and I think it will really help frame this for people. And also one of the other thing I love about it is just like it opens the door to so much other research. Like
Yeah.
it's just,
We hope so.
it is very generative of research ideas. So I hope,
Thank you.
maybe some students get excited about this.
Yeah, we think about it as a bit of a call to action. So, get in touch. We're really happy to talk through stuff with people.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.